Hi, good afternoon. My name is Alexandra, and today I'm going to talk about the supermassive stars. But what I'm going to talk more is about the end life cycles of the stars and what happened after that. So what I want to start with to say that supermassive stars, they are much bigger than our star, and most of their life cycle they are burning hydrogen into helium, and this helps them to be stable. So you can just imagine the tug of war. We have a gravity. I have a gravity here on this side which pulls everything like inwards, and I have an energy from the burn hydrogen that pulls outwards. So this is creating the balance which helps the star to be stable and keep it from collapsing. So as the stars gets older, they are going through some changes, and after they use up the hydrogen, they turn into the red supergiant. So from the name you can figure that's a big red star. And this phase they start burning some heavy elements like helium, carbon, oxygen, and even up to iron, and grow much bigger. So to understand the scale of this event, you can just look at the picture on the right side. You can see the bright star in the middle of the image, in the center of the image, and the hot cloud of gas around the star, which is just ejected into the space. Next slide. So eventually the star makes iron in its core, and iron is a quite different thing because it does not generate an energy, and without the energy, the gravity, so you remember the tug of war, if there will be no energy, the gravity is gonna win, and when the gravity wins, it's make core to collapse. So when the iron core meets the critical mass, about 1.4 times of the sun, it's gonna collapse within a second, and this collapse causes a huge explosion which is called type 2 supernova. This explosion is actually essential for the galaxy, for the cosmos, because it's enriched it with heavy elements, which is essential for the formation of planets and life. Next slide, please. So what happens after the supernova explosion? There are two things that might be left behind, and the first one is a neutron star. So the neutron star is gonna form from the explosion if the core is remnant between 1.4 to 3 times of mass of the sun. And the second one is a black hole. So if the core is remnant more than 3 times of the sun, there will be a black hole. Next slide. So I want to start with the neutron star. They are very dense and small, but they are actually much heavier than a sun. They know for things like magnetars, which have like very strong magnetic fields, and the pulsars, the neutron stars, which spins very quickly and send out waves of radiation. So the pulsars can spin between 10 to 10,000 times per second. The neutron star, they also have a complex structure. The core and crust, they composed of neutrons, protons, and some exotic particles like hadrons and quarks. Next slide. So on the other hand, we have a black hole. But black holes have such a strong gravities that not even the light can escape from them, which makes them the most mysterious thing in our universe. There are 3 types of the black holes. The first one is a stellar mass black hole, and it's formating from the supermassive star explosion. The second type is intermediate mass black hole, and it's formating when 2 small black holes and supermassive stars are merging together. And the third type of the black hole is a supermassive black hole, and they are residing in the center of our galaxies. Scientists actually can see gravitational waves, which are ripples in space-time when 2 small black holes are merging. Black holes, they have a range of masses from several times of the sun to the million times of the sun. The very strong gravity can bend space-time and light, which lets us find them by using gravitational lensing and X-rays coming from equation rings. The interesting fact that black holes can emit particles due to quantum effect near the event horizon, causing them to lose the mass and eventually evaporate. If we're talking about my personal preference, I find black holes more interesting because all our knowledge about the physics breaks out when we are coming to the black hole, and it challenged our understanding about the gravity and quantum mechanics. Furthermore, supermassive black holes they play a crucial role in the formation and evolution of galaxies, influencing the star formation and galaxy morphology. Thank you for watching, and I hope you have a good day. Thank you.